Okay, guys, what we're gonna do, it's been 2 minutes? Yeah. This is just something we're gonna try to give a little introduction to. Having a total understanding of this is not necessary when you get into PLCs. You're gonna get into this in a lot more detail. Now, the numbering system that you have been dealing with all your life, hopefully by now, is what we refer to as the decimal numbering system, or also referred to as base 10. And what we mean by a number system, most of y'all didn't learn this. So if I wrote down a big number, what do y'all call this digit right that occupies that spot? What'd you learn? You learn ones, tens, hundreds, thousands. Well, the actual way a numbering system runs is that each digit holds a weight of the base. So decimal is a base 10 base 10 numbering system raised to some power. So that would hold a weight of 10 to the 0 power. This would be 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, and how far would it go? Forever. Then we get into, this is technically called the radix point. But most people call it according to the numbering system that they're dealing with. So y'all probably learned it as the decimal. And then if I said 3, 2, 8, this right here would be 10 to the minus 1, or 1/10. So anytime you raise a number to the minus power, you just flip it over, right? So 10 to the minus 1 would be 1/10. This would be 10 to the minus 2, which would be 100th, right? And this would be 10 to the minus third, which would be 1,000. Now, if you converted these over, so any number raised to the 0 power is 1. That's our units, right? Any number raised to the first power is itself. And then this would be 100, this would be 1,000, and this would be 10,000. This would be 1/10, this would be 100th, and then this would be 1,000. So basically, you just take these on this side and do what? Just put a 1 up. So if I wanted to see what weight this digit right here held, then it would be 3 times 10 to the 0, but that's 3 times 1, so it holds a weight of what? 3. And the 9 holds a weight of 10 times 10 to the first. Well, 10 to the first is 10, so it holds a weight of 90 toward the overall weight of the number. Now, the problem with the decimal numbering system, computers hate it, because it's got to deal with 10 combinations. So when we have computers like to deal with very simple things. They like to only deal with 2 digits, because 2 digits, what advantage does 2 digits have over 10? Well, if I wanted to represent the base 10 numbering system electrically, I would have a big problem. So how would I represent a 3? With 3 volts, maybe? Then how would I represent a 93? With 93 volts? Or maybe have one wire carrying 9 volts, the next wire carrying 3 volts, right? So it'd be very hard, and plus voltage is hard to maintain over distance. So we even see that in our power station, right? So when Alabama Power generates power, it is regulated, but by the time it gets to my house, we're out there 120 volts plus or minus 10%, because we're going through all that watt getting from the power station to our house. We're going through a bunch of wire and a bunch of transformers. So if I only had 2 states, then I could represent it with 1 voltage would represent a 1, and a 0 volts would represent a 0, right? So now instead of me trying to transmit this information, I'm just trying, and the analogy we use, it would be like we have somebody up here on the hill up here with a flashlight, and it's got a switch on it where they can put 10 different intensities. So all the way off would be a what? A 0. And then they start flipping them, and you're over here trying to record numbers. How many? And he's trying to send you this number right here. How many would get that right? Well, I might interpret a 1 as a what? As a 2, or you might interpret a 2 as a 1, or vice versa. But how far could that person get away, and you could tell if the light was on or off? A long way, right? Y'all understand? So computers and PLCs and these computers that are controlling these systems now. So what is a programmable logic control? It is a computer that is designed to run machines. So now it's a computer. So computers don't like the decimal number system. So how can it store this display up here as a decimal number system? It's real easy to turn dots off and on, right? You understand? And our eyes blend it together. So computers do not use the decimal number system. It might display stuff in decimal for me, but that sucker has no idea what a 10 is in decimal. All it's done is turned it on a pattern, right? So if it sees a 10 in binary comes in, it says, well, that means I need to turn on this dot, this dot, this dot, and this dot. Have you ever looked at the display on a computer? Let me go get my